my name is Thiago Sanches. I'm a fourth-year PhD student at the University of California, Davis. And today I'm going to give a brief talk about the advantages of transect sampling compared to discrete sampling for environmental DNA applications. First of all, sampling in aquatic system is very diverse. So for conventional methods, you can have like kick nets, you can have cast nets, you can have tow nets. The same diversity can also be observed by eDNA sampling. We can sample at different depths, different manners. So just try to break down this diversity. We can try to break down between point sampling, transect sampling, conventional methods, and environmental DNA. For the conventional methods, you can have like a cast net, and you can have transect sampling. And transect sampling have a higher chance of just passing through a fish to have a higher detection rate. What we're trying to prove here is use a mathematical model to prove that with transect sampling for environmental DNA, we're also going to see a higher detection rate. So our model is going to be built from the ground up. So we're going to start with like a single fish that's going to be producing DNA at a certain rate. This DNA that's produced can be degraded at a different rate. And this DNA can move through the fusion or through advection that's going to be a root velocity. Once the systems enter equilibrium, it's going to add up to 0. And the environmental DNA distribution is going to follow a negative exponential distribution. This is a solution right here for this equation. And just to try to understand, you can see like this plot where you have like our little fish at 0. This next x-axis is going to be this from the source, and the y is going to be the DNA concentration. For if you have very little advection, what you're going to see is that the DNA concentration is going to be very close to the fish, and it's going to be very little farther away from the fish. But if we add velocity, a lot of the DNA is going to be present downstream of the system. To sample from the transect sampling, you just have to imagine that every little piece, you're going to just sample depending on the pump flow, the DNA concentration, and how much time is spent there. So the integral is going to be the solution for our transect sampling. We're going to be able to solve it, but we won't be able to show it. We're just going to show the results. So here's the discrete versus transect sampling for rare species. Here we only have like a river of 600 meters, and we're going to be showing probability of detection for this each segment. For discrete sampling, what we observe is that if we're very close to fish, we have a very high detection rate of near 1%, near 1. Meanwhile, for transect sampling, we're going to observe a much lower detection rate, but it's going to be a lot more broad. This length of this is going to be dependent of like the transect size, and just saying that as long as your transect passes through the fish, we're going to be able to detect it, but at a lower rate. But once we don't know like the fish locations, what we're going to be able to see is like the frequency of positives that we're going to see throughout our system. So for discrete sampling, what we observe is that most of the time you're going to get negative results. Meanwhile, for transect sampling, you're going to be able to detect the fish a lot more often. Meanwhile, for common species, what we observe is the same pattern, but in a different case. So for discrete sampling, we're going to be measuring basically like how close we're going to be to the fish. If we're very close to it, we're going to be detecting it, but otherwise we won't. But meanwhile, for transect sampling, what your probability of detection is going to be proportional to how many fishes you process through the transect. So it's going to give you more information about the global distribution of fishes overall, and also it's going to give a much higher detection rate, considering we're going to pass through several fishes throughout the transects. So in conclusion, for low advection systems, we're going to observe higher detection rates, and we also have like a higher repeatability, and with faster, and we're going to have less chance of contamination. I just want to say thanks to the lab, and thanks to our sponsors from the GBL, DWR, USBR, and ICF. Thank you.